All right, hello everyone. Welcome to the summary of session 9 of the free PMP training. Session 9 took place on Friday, 21st of February at 7 p.m. GMT plus one. So as usual, here's the summary of session 9. It went for about 2.5 hours. We've covered 60 slides. We've had 25 in chapter practice questions, and we had the chapter 9 test questions. Okay. 10 test questions, and we've covered the entire chapter 9, which was about quality management. Okay, so as usual, here's the summary of the session and the top 10 slides. We started the session with a recap of the previous sessions and chapters. Then, we started the chapter 9 quality management. First, we understood what is quality management plan, which, includes the tools and techniques, for in the waterfall project management, tools and techniques for managing the expected quality, delivering the expected quality, and we explained how quality management plan is part of the project management plan. Okay, and we also talked about quality audits, and we said that the audits they repeat in a waterfall project because with the audit we cover or we review the application of the processes or the use of the planned processes. Okay, then we understood the difference between quality and grade. So quality is the sum of characteristics expected to be in a product. Grade is the ranking between products. So it's always good, it's always better to have a low grade product, like with like a small number of features, but with zero defects, which means high quality, than to have a high grade product, like with a lot of features, but with a lot of defects, which means low quality. We also, went back to discussing difference between the regulations and standards. The regulations are de jure laws, and the compliance with regulations is a must. But standards, these are best practices. We call them de facto. We saw the ISO series as an example of standards. Kaizen, then we saw Kaizen, which is a philosophy, for continuous improvement. Six Sigma, which is, a technique, for improving the quality of deliverables, detecting and trying to reach 99.99966% defect-free products, all right. Then we saw a very important slide, which is the difference between quality assurance and quality control. So quality assurance, this is a preventive process. It's proactive. The purpose is to try to, assure quality while developing the product. Quality control or quality review, this is, testing in order to detect defects after the work is completed. Okay, and then we saw also some quality control tools such as statistical sampling, inspection, like flow charts, histograms, Pareto charts, scatter diagram, cause and effect diagram, check sheets, control charts, etc. Of course, we started with, we went through these tools one by one. We saw histograms, we saw Pareto charts, where we try, to identify 20% of the causes which have around 80% of the impact. We saw a scatter diagram to analyze the relationship between two variables, the run chart, to control check the process. Control charts, with the upper control limit, the lower control limit, and with the rule of seven. We saw that as well. We saw also the PDCA cycle, the plan, do, check, act for continuous improvement. Okay. We saw the difference between also accuracy and precision. Okay, we understand that in one of the questions, to be accurate means, to hit the target, but to be precise is like to, achieve the same results after each action. Okay, we also saw, something very important in quality management, which is root cause analysis techniques, such as the cause and effect diagram, which is called fishbone Ishikawa diagram. It's got the shape of a fish, where we write down the effect, what happened, and then the possible causes, each possible cause on a bone. This is a team exercise. Okay, we saw also the five whys diagram, or we can call it even YY diagram, which is again another root cause analysis tool. Okay, to ask why 5 times in a smaller group and try to understand, go back to the root cause of the problem. We checked also, we saw check sheets, which are tools for tracking different things like issues, etc. And one of the important slides was like the cost of quality. We said, how, quality costs either way, okay? If we develop and deliver conformant products to the expected quality, then to be conformant means we will incur cost. This cost will be incurred during the project in order to avoid failures, such as prevention costs, like provide the team with training, improving the processes, updating the documentation, and also appraisal costs, like buying a machine for testing, doing regression analysis, having inspections, internal with internal resources or external. All of this will cost us money, and we will incur this money during the project because we would like to be conformant. And in case we are not conformant, then we will also incur cost. Like if we develop and deliver products which don't respond to the customer's expectations, then that means we're not conformant, and this cost of non-conformance will be incurred, can be during or after the project because of the failures. Like, if during the project, it's called internal failure cost in case we will do some rework, corrections, scrapping, maybe refactoring, and it can be even some external failure cost, in case, for example, we'll have some, liabilities, cover, the errors with the warranty work or lose the reputation in the business. Okay. So this cost of quality is quite an important slide and mindset. And then finally, we saw the technical debt, which is considered as an internal failure cost. This is the behavior of delaying the necessary corrective work, and this would impact, the quality of the deliverables, and the longer, the costlier. Okay. Then finally, we've had the tools and techniques of the chapter and the 10 test questions of the chapter. And as usual, here are the top 5 practice questions we have picked for you, from this chapter. So, question one: you're managing a project to develop a new software product. Your team follows a widely accepted industry practice for coding standards, but there is no formal regulatory requirement enforcing it. However, during a stakeholder meeting, a senior executive insists that the team must follow a newly published government mandated security protocol that applies to all software projects in your industry. Which of the following best describes the difference between these types of standards? The industry practice is a de jure standard, while the government mandated protocol is a de facto standard, and this is wrong. It's actually the opposite. The industry practice is a de facto standard, while the government mandated protocol is a de jure standard. This is correct. Both the industry practice and the government mandated protocol are de jure. No, this is wrong. The industry practice is a de jure standard because it has been accepted over time, and no, this is wrong. The industry practice is not a de jure, it's a de facto. Okay. Question two: you're managing a project for a manufacturing company that aims to improve its production processes. The organization has decided to align its quality management system with ISO 9001 standards to enhance consistency and customer satisfaction. As the project manager, what is the best approach to ensure compliance with ISO 9001? Conduct regular quality audits to verify that processes align with ISO 9001 requirements. Focus primarily on product inspections to ensure defect-free deliverables, where it's almost impossible to achieve defect-free deliverables, like not at 100% level. Implement Six Sigma methodologies to eliminate all defects and comply with ISO 9001. No, that's not. Six Sigma, is not, ISO is not related to Six Sigma like directly, and the purpose of Six Sigma is not to achieve 100% defect free. That's wrong. Ensure that ISO 9001 requirements are only applied in the final phase of the project. That's too late. So the best answer is answer A, to conduct regular quality audits to make sure actually our processes they align with the ISO 9000 requirement. Okay, 9001 requirements. Question three: you're managing a software development project and the company follows quality assurance best practices. A stakeholder requests that you focus primarily on final product testing to ensure quality. However, you explain that quality assurance is different from quality control. So, which of the following best describes quality assurance in project management? Conducting rigorous inspections to detect defects before the product is released. Actually, this is quality control. Using statistical sampling techniques to evaluate the final deliverables compliance. This is quality control. Applying root cause analysis after defects are found to identify corrective actions. No, actually not. This is not quality assurance. This okay. So the right answer is answer B. Implementing processes and audits to prevent defects or preventing defects. That's the key word. That's assuring quality with a proactive approach and improve overall quality okay, of the product. Question 4. A project manager is reviewing quality control and reports for a manufacturing project. The team has tested multiple batches of products, and the results show that the measurements of each batch are consistent with each other but slightly off from the required specifications. How would you best describe the performance of the manufacturing process? The process is neither precise nor accurate because all measurements are slightly incorrect. The process is accurate but not precise because it sometimes meets the required specifications. The process is both precise and accurate since the measurements are close together. The process is precise but not accurate because the measurements are consistent but not meeting specifications. So here, the results show that measurements of each batch are consistent. So if they're consistent, that means they're accurate, but slightly off from the target, which means they're not precise. So the right answer is D. The process is precise but not accurate. Okay, because the measurements are consistent. So if they're consistent, that means they're precise. Okay, but not accurate. Sorry. So the process is precise, okay, but not accurate because the measurements are consistent but are not meeting specifications. If they're not meeting specifications, they're not accurate, but they're precise because they show the same measurements, okay? And last question, during project execution, the sponsor informed the project manager that the produced waterproof watches should be tested in real underwater conditions in order to fulfill the acceptance criteria. When the sponsor's advice was applied, 10% of the already produced watches did not pass the test. What should the project manager do next? Consider this as an internal failure and correct defects without submitting a change request. Consider this as an internal failure and submit a change request to fix the defective products. Consider this as an external failure and correct defects without submitting a change request. Or consider this as an external failure and submit a change request to fix the defective products. Since is the sponsor who informed us, to test, that's internal, that's not external, because external is mainly for the customer. So C and D and out. And this is 10% defective watches. So fixing them, we have to go through a change request. So the right answer here is internal failure and fixing them through a defective so through a change request. Okay, so this is the answer. Okay, so thank you so much. See you on session 10 on Monday, 24th of February at 7 p.m. GMT plus 1. We will go through chapter 10, which is very important chapter about risk management.